All right, then let's go back to water. We got H2O. We've got one big old fat oxygen with two little baby hydrogens hanging off of it. There's a chemical bond, which means they're sharing electrons here. Okay. And since they're sharing electrons, let's kind of zoom in on the oxygen atom specifically. Oxygen has a atomic number of 8, and that number 8 tells us there's 8 protons in the nucleus. Okay? It also has 8 neutrons, and 8 plus 8 gives us the atomic weight of 16. Because compared to the mass of the proton, the mass of the electron is almost non-existent. So the protons and neutron make up the mass of the element. So we see there's 8 electrons orbiting this thing. And then hydrogen. Hydrogen is number 1, which means it has 1 proton, so its atomic weight is 1. Now, I mentioned the chemical bond. They're sharing those electrons. Now, because oxygen is a much bigger atom, okay, in essence, 16 times more massive by weight, these shared electrons, because of the more massiveness of the oxygen, the electrons will actually spend a little more time hanging around the oxygen molecule than they do the hydrogen end. And since electrons have a negative charge, that makes this end of the molecule just slightly negative in charge. And it makes this end of the water molecule just slightly positive. And because of that separation of charge, one end being slightly negative, one slightly positive, it's called a polar molecule. Now, not all molecules are polar. Here's an example of one. Carbon with 4 chlorines around it is a polar molecule. Okay. Okay. But not all molecules are polar. Okay. And out of the textbook, Dr. Weil, our author, has a short video explaining this. So let me